Okay, and StreamYard tells us we are live, so good evening.
Yay.
Good evening from Belgium and the Netherlands. Welcome to session 4 of day 3 of the J Champions conference. I'm Frank, the moderator of this session, but the star of this show is, of course, Elias Nogueira. I met him the first time at a JUC in the Netherlands in 2023. And we had an inspiring talk about testing. I was impressed by his knowledge and enthusiasm. So I wasn't completely surprised when he got elected as a Java champion only a few weeks later. Elias presented at various user groups and conferences on testing approaches and helps engineers to develop a quality mindset to deliver bug-free software. Whew, that's a mouthful. As a Java champion and Oracle Ace Pro, he actively contributes to the Java community, advocating for best practices and innovation in testing. And I see that your camera starts glitching again from time to time, so hope that
Yeah.
was not that bad during the talk. So in the talk, he will address common testing pitfalls in distributed systems with code examples and practical tips. And in an hour, we will be able to build fast, reliable, and realistic test pipelines that boost confidence in complex systems. I'll keep an eye on the questions, Elias. Will we handle them after the talk?
Sure. We can be during the talk actually, if
Okay.
it's better. 'Cause when I
Whatever
go to
works
some
for you.
topics, yeah.
Yeah, whatever works for you, I will try to highlight them if possible. Okay, the floor is yours, Elias. And
Awesome.
everyone, have fun with the session.
Thank you so much. Guys, I think unfortunately my camera is flickering. I don't know exactly why. It's my day-by-day camera, but yeah, you see some blinks. It's not you, it's my camera, okay? Starting as usual, and I will explain what I do today. So entire screen, and you guys will see. Now, yes, this guy that with less white hair, but yeah, the time comes for everyone, and no glasses. Now it's new things about me. So my name is Elias Nogueira. Today we'll talk together about testing. Normally I talk only about testing, which is nice, which I love to do, and which something that we should do more as developers, right? Because we don't like to fix bugs because it takes endless, and then we need to do something that is might be boring, and we have a lot of techniques and things to do in order to not repeat ourselves in terms of fixing or facing any bug. Cool. Just a little bit more about myself after that introduction. I'm a software engineer, or you can call me anything. I try to be helpful and help everyone in the company. I'm originally from Brazil, but I live in the Netherlands nowadays. I'm one of the Java champions as well. That's why I'm here, and I'm one of the Oracle Ace Pro for Java as well. What we're going to do today is how to test distributed systems. And I know that when we talk about distributed systems, we have a different ways of architecture, challenge a lot of things, but I will show you how to do in terms of the talk, how to fix few problems. And in order to fix that, of course, I will talk about the problem itself, and we will learn how to solve it. After that, we will have code examples, and in the end, we'll have the takeaways for that. So let's talk a little bit about the architecture. This is one of the architectures that I've been working for some years. Now it's a totally different one, but let's try to understand a little bit together. And by the way, everything here is more for educational purpose than like real life examples. Of course, like professionally, we do way more things. Here we show you in the simplest way possible how to overcome those problems. But of course, based on our context, will be a little bit different, but idea will be the same. The examples will be a little bit silly, but you get the idea of how to implement in your way. So the architecture for this talk. Let's think that we have a banking platform. And then let's go from the top to bottom. We have the web and mobile apps. That's normally we get our cell phones. I want to do a transfer. I want to talk with someone in the bank. I need to get some money for my mortgage or for something to buy a new car, whatever. Then when we have these web and mobile apps, we normally communicate through APIs to a lot of different services. And those services, depending like if you need to get some money, it's a digital lending, it's a lending. If you are doing any kind of payment process, credit card and stuff, you have the banking platform. You have a lot of platforms, right? In a real bank system. Normally, after that, like let's say in below the levels, you have to support that common services, any kind of enterprise integration, unified security, and a lot of stuff. And then you have the connections, with a lot of different systems. One, of course, it's your own core bank system that you can develop by yourself or you can buy from someone, but you have the core bank system. You can have fintech partners to enhance the features or the products you offer to your digital banking or your banking platform. You can have connections with open banking. This is more or less, in a short way, how a business view of a bank system like works in a high-level architecture, right? Zooming a bit in this architecture. And for example, in digital banking, which we normally can relate it more, we have a lot of different features, right? Of course, we do payments, we can take loan, we can see credit cards and all the transactions about the credit cards. I have things that's like dashboards and I can configure and see how I'm spending the money. And of course, there are a lot of different services or APIs that we don't see sometimes, like limits, audit part, some part with the accounts, access control. When we think about the digital banking platform, we have endless services with a lot of microservices to do one or two specific things. For this general overview, I want to zoom in a little bit more, and then will be the examples in the talk about the payment system, because it's super common, super easy to understand. And of course, what I have implemented here, I'm showing to you right now, it's not a real one. A real one have like way more things in terms of microservices. But let's focus on the blue things. First, I have like something called payments in a group as payment order in the right side, payment options, batches, and payment integration. This is more or less like this. Payment order is the normal service to do payments. I have options to do payments or integrations to do payments, like I can do a normal payments, like transfer from accounts to accounts, it's a payment. I can have partners or configurations for partners that can pay through Agent, Molly, PayPal, other stuff, right? And I can have this as a batch process. Instead of one payment, I want to pay 10 times the same, I don't know, the same company, or I want to distribute the money across different accounts. This is, let's say, core payments. Around payments, I can have a lot of things. We will have a lot of things. One of the two main ones, let's say, that I will show you this today, it's in the right side, anti-fraud system, a third-party system that like can see if like some kind of payments looks fraudulent or not. And of course, an audit part. Everything that's payments related should be audited because it's regulated by SOX. And other, like in any country, we have specific regulations for that as well. And I need to generate a log for that. And of course, we can have a lot of other different things. For example, for batches, when I process a batch, I cannot, like, I won't pay or not process this when it's during the weekend, right? So I need to have other service to help me out, or having a calendar where I can process and actually dispatch those batches or not. So you can see that it can get like way complex. And of course, everything like this, there's a communication for core bank system. Like those are microservices, and they need to communicate actually with all the data we have. Cool. And given this architecture, only for payments, and imagine like if I go back, we have a lot of different parts, right? So payments is that first blue one. And if I zoom in, probably in other things like cards, for example, loan, I can have a lot of different microservices with a different way of communication between them. This is only one. It's a simple one, but it seems a lot, but it's not. So we had a lot of testing challenges on this kind of architecture. 5 of them. The first one is test with real dependencies, then support of multiple databases. By the way, in that architecture that we are doing, like for a banking platform, we were supporting different databases because we could have different customers with different necessities for databases. Another thing was the mock dependencies, which is really challenging. This is still for any kind of business. Test asynchronous request, as we have a lot of message brokers or things to do asynchronously. We need to guarantee that it can test somehow. And of course, API governance across multiple teams, it's a problem as well, a good problem to solve, because we need to have the same, like more or less the same patterns in terms of API. I will not talk about all the 5 ones. I will talk about only 3 with the examples. First one will be the support of multiple databases, then how we can deal with the mock dependencies, and how we can test those asynchronous requests. Again, those will be super silly examples, but you will like instantly relate with your day-by-day activities probably and say, okay, cool, I got the insight how I can solve this problem in my context. So coding example, it will be really simple. I have a payments API, super silly one. Then I have an anti-fraud system that will be a third party. I don't have, like, it's an external connection. And then we have an event listener event in between, more or less to simulate another API, which will be audit, consuming those events. And then, of course, I more or less want to simulate how I can consume an event, as an event is asynchronous, right? Even though it's super fast, it won't happen instantly when you run a test. First thing to test, one application with multiple databases. We do have some problems, right? Because modern systems often support different databases. When you sell software, even needs to support your product. Sometimes, like, even not selling your product, but you might support like 1, 2, or 3 different databases by different means. Integration tests for that, when you do support multiple databases, usually runs in memory, right? So you cannot get any database specific issues. It's pretty common as developers. Okay, we do a lot of like really nice stuff, but when we are running the test, we are running with H2, for example, in the memory. And if we want to test with multiple databases, we most of the time we don't try to solve this problem. We test it sequentially. So I get all the things a little bit more slower. And if I have a pipeline to do that, the pipeline will be slower as well, because it will be n times plus the execution time you do per each database. We will discuss about it. So common problems is usage of in-memory database, don't show real problems, and high effort for real database. So sometimes it's a lot of people do a lot of manual steps. Of course, most of you, if not all of you, knows test containers that can help us on that, but we can improve this a little bit more. So how we can solve those problems? With parallel tests and supporting, of course, inside a container for a database support. What are we gonna do? We're gonna do this payment part with 3 different databases. I use actually 2 databases, but I can support n, right? Like MySQL, MS SQL, Oracle, a NoSQL database. I used two SQL ones, MySQL and MS SQL, Microsoft SQL, just to show those differences. So showing the code first and my ID. And I just need to jump in any specific branch. By the way, let me just explain the system a little bit because it's nice to explain. Just for us to follow all the examples, and then I will show you these different databases. So I have a super silly application here based on Spring Boot, and I will show directly the service for that, for the payment part. And we can see that we do have, a create payment and a update payment. Simulating like I have a payment request to pay, and then I pay the payment. When I create a payment, it's a payment request, and logically, the status for that will be pending. And of course, I have transaction ID is a lot of different more stuff, just super silly. Remember, it's educational purpose. So I have only few fields here, and then I'm just like updating. As soon as I pay that payment request, of course, I update that payment. The status is paid. If everything goes as expected, if not, of course, I can do other stuff. And we will do other stuff in terms of checking if that payment has some fraud or not. It should look like a fraud. Of course, we want to deep dive on that, but this is one of the use cases. Okay, super silly, payment request, payment updated as doing the action of payment. When we have tests for that, and I have integration tests here, and I expect you guys will have integration tests for those kind of things. I have a normal thing that is having it through mocks. I'm using mock MVC here. So I want to get a payment. I want to get all payments here. And then I'm just trying, okay, get a payment and learn 404. But of course, I can have way more things. When I get a payment, I'm actually creating payments through the repository, performing like defined, like through the API directly, and just getting the results. Don't look at the code. It's super simple code as well. We can be better, of course, but just for explanation. If I run these tests, and I will just remove this active profile, everything that I run here will be by the default database. And just to take a look, this is too bright on my second screen, but if I, if I search by H2, I will see that it's in memory database using H2. Why is that? Of course, because I have my resource here in my application. It's super common when we do this in Spring. Look, data source, H2, right? Super silly thing to how to fix it. Normally in Spring, we do create an application test for that. And for the application test, what I can do, we can use, of course, test containers to be the data source. And here I'm using MySQL, right? And to basically take care for me about all those stuff. Instead of running in H2, I can run in MySQL. Why this is now a little bit better? Because I'm running in a container, a real database. If there's any problem with any schema, whatever I'm trying to play with any tool, it will show a real problem. Whatever I'm trying to do, any operation to save, delete, do all the CRUD operations, it will show a real problem as a real database. After of course, we have those data sources through test containers here configured. A simple thing to do, it's of course adding the profile in Spring as simply test, right? just to match that application profile that we use MySQL. As soon as I run it, you can see that it's still running. It's waiting a little bit for MySQL. And now it runs everything. If I just try to find here H2, it's just loading the class path because I have the dependency, but you can see no more than that. But if I look at MySQL, I can see that payment service is using a true task container MySQL. And you actually use that database, which is a real database in a container, to do all this stuff. Cool. It's really important if you guys are not doing this yet to do this, because you guys will have specific problems with database. There is no way to run. Cool. This is a super silly thing, right? To run one database. What if I want to support more databases? Super simple as well. Let's just go through the next one. In order to support other databases, of course, still in the context of Spring Boot, we can have different applications YAML files. I have one for H2, one for MySQL, another for Microsoft SQL. And what is the main difference? Of course, the data source per database will be different. Of course, this is MySQL. This is Microsoft SQL here using. And only for Microsoft SQL, the SQL Server, we need this license to auto accept all the terms and conditions they add there. Now I have super silly thing with Spring that I added different applications, right? But when I need to run the tests, we get a problem to run into multiple profiles. What I'm doing here and what I will show you. I have this Spring profiles active, right? So in my Pwn XML, I have a profile section where I'm saying, hey, the default is H2. Of course, shouldn't be, but I'm just saying the default is H2. But every time I want the profile MySQL, a Spring Boot profile will be MySQL, which will be application-mysql.yaml. If I want MS-SQL, it will be the same application -msql.yaml. And this I can do basically, if I want to do tests in different ways, Maven clean test -profile MS-SQL. And then I can manage those differences, right? And I can run everything now in the SQL Server. And of course, it's trying to get the connection first. And now it gets connected. And now it's running the tests. And of course, I have failures because I'm running everything. But everything is not working properly because you see later. But I have like 6 runs, 1 error. I will just ignore this error for now. But it runs with MS-SQL. Cool. Not the drawback here, but a little bit of problem here is that if I want to run with different databases locally, I need to run through these profiles, right? And I need to set the profile per database to run. And it's not that ideal for us. Let's go back to the slides and let's show different thing. When we need to run those 3 different databases, let's say, we, for example, have like 3 minutes of integration tests per database, which is quite high depending on what the application is. But let's say we need to run and we want to run those 3. So we will run in 9 minutes because we run first from MySQL, after MS-SQL, and then to Oracle, right? So run sequentially is a bad idea. It's way better than running a memory database. But it's still like we want to be faster in terms of knowing if there's any issue or not with each database. How we can solve this? Of course, it's running in parallel. But to run in parallel locally, it can consume a lot of resource from your own machine, right? Because like you already have like your preferred IDE, then you have Docker, then you have, I don't know, Spotify, which consumes a lot of memory nowadays. Then you have a lot of applications running, so everyone's competing for the resource in your computer, right? Running locally, it's not a that good idea, but it's one idea as well. But the better to do that, let me show here. Yeah, is through a simple thing called pipelines. I don't know which tool you guys are using for CI/CD. Here, I'm just using the project in GitHub anyway, so I'm using GitHub Actions. And just to show how we can do this in an easy way, running parallel, I can just say to my GitHub Actions, I have the jobs here that will set up Java, cache, and that will run this integration test. And when I run the integration test, what I'm saying here, it's, hey, this is GitHub Actions specifically. I have a strategy that is a matrix, and those matrices are profiles, and those values for the profiles are MySQL and MS SQL. I won't run Oracle because it will take forever as well. Will consume a lot of it, even in GitHub Actions, right? And there's some restrictions that now. So then when I run it, you can see that I'm doing Maven test. I'm running just a specific test just to show you guys. And then I set the profile as the matrix that is defined here. And then you guys can configure every pull request, every merge request, anything, any new update in the branch, you guys can trigger this. And how it looks like in the project. So I have the action here. So call it just build and test. I will run this workflow, and you guys will see that I will refresh. It's doing the build first, and you can see waiting for pending jobs, and it's a matrix for integration test. As soon as it runs, and two jobs. And those two jobs are the two tests running in parallel for MySQL and MS SQL. So I have two integration tests running for different database. And of course, you guys can apply this for any kind of strategy, not only for database, but this in terms of integration tests, when you need to support multiple database, this is the best way to go, one of the best ways to go. And it's really doing the test? Yes. So it's pulling the image here, and this is MS SQL, right? Yes. So we can see that somehow test container is pulling MS SQL. And if I take a look in MySQL, and MS SQL finished the MySQL as well. And then during the run, if I get MySQL, come on, I'm knowing that it's pulling the Docker image with test container for MySQL. And you can see that, of course, it won't be exact the same time when we run, but it runs like, instead of waiting, let's say 1 minute, 2 minutes, 1 minute per database, I waited only 1 minute, everything in parallel. Cool, super simple, really, really simple. And the first time I presented this talk, I received a really nice feedback, which is super simple, but like the guy told me, it's nice that the basic can solve a lot of problems. So what I'm showing for all of you is basic stuff when we do test. And by doing the basic stuff, we can really test better and test any kind of architecture. And it's really nice because it's true, right? And you guys will see that like other examples will be even a bit simpler, and you solve our problems. If you guys have any questions during this part, pop up the question. I will be really happy to answer all. And then going to the next part, which is the takeaways for that. So, integration test all the time must validate behavior across all target database. In this focus that we are talking about databases. Parallel execution speeds up the feedback, and of course, will reduce the time you are waiting for this feedback on CI. And creating this approach of add everything as a container, like, will give us this feeling of production-like, and we can get more confident about running our tests because we are really using that tool. It's not anything mocked. We are really using that. And if there's any problem, you experience the problem before a customer will experience that. All right, let's talk about the third-party systems. This is basically the most fragile thing that happens in any company. It's a hell. And I'm every company that I work at, and if I talk to any of you, you see, hey, we are having a lot of problems with third-party systems. So, in-code mocks are really good. We do that. We must do that, but can't solve all the problems. It will solve the team problem. And for example, using a sandbox or QA environment for a vendor or a sandbox, whatever, it might be really, really, really flaky, right? I don't know. For example, we need to test something with PayPal. PayPal have a sandbox. Sometimes it's out. Sometimes it gets updated. And all the requests that we normally send that were working, it's not working anymore. Maybe because they forgot to add something in the docs and we missed that, or we just missed it that they updated something, right? Mocks will give the confidence, but as soon as you hit an environment that you should hit, then we have this hell of like managing that. And for example, we will do this with more or less with anti-fraud system. So we will communicate with this anti-fraud is a third-party system. So the first thing, the first question you need to ask when you're trying to do a test for a third-party system is, can we trust the third-party system to run our tests? Most of the time, the answer is no, I can't. So tests that rely on them will be flaky and slow, and local mocks can be inconsistent. And I will explain about local mocks. If you have a third party, probably more than one team is using that third party, right? Then if I create the mocks for my team, it will be literally the same mocks that I need to use for team B, for team C, for team D, and whatever. So it's basically a lot of code duplication. And imagine if we have a new version of that third party, we need to update because there's a new breaking change we need to adopt. Then a lot of things we need to do basically the same stuff. And it's not that scalable, right? We lose a lot of money. We spend a lot of time doing that. How we can solve this? Through service virtualization. And more specifically, again, with Docker, of course, adding a container on that, but using WireMock, which is super nice too. What is service virtualization, by the way? There's a full explanation, but I'm highlighting the most important parts. It's something that will simulate the behavior of external system instead of relying on real services. So teams use a super lightweight standings that will mimic the real behavior of that third party, of that external system. So we will literally simulate the behavior like we do with mocks, but with something that can live and can be consumed by others. So basically, when we have a service utilization, the basic activity we'll do is to share this somewhere as an environment or as a container or deploy this in the Kubernetes infrastructure. But the common way we can use WireMock as a service utilization inside a container. So we can even have a Docker Compose or a Docker standalone just to manage that, or deploy in any infrastructure that supports, of course, container like Kubernetes. And all the teams actually will go to the service virtualization to do their mocks instead of having their own proprietary code. It has a lot of benefits. I could think about, okay, I want this, not service virtualization, but I want to solve this mock problem of creating another library that will manage that. Cool, it's also possible, but then still mock. And what service virtualization in terms of API can bring you some benefits is that you are actually doing HTTP requests to a server. Even though it's a local server, of course, you still start managing different problems and actually making sure you won't have any kind of connectivity problems, performance, and whatever. So the virtualization in this part will replace external calls with WireMock hosted in a container. We'll share these mocks across any teams or different teams to make it for collaboration and consistency. So imagine that in that situation I told you, there is breaking change in this third party, and now I need to add that breaking change, right? Adopt that. If I would have a lot of code, each team developing their own mock, it's a lot of effort. Now with a central point, I just go there, update the breaking change, test with 1 or 2 teams, everything's fine. I can say to all of the teams, hey, breaking change adopted, this is the dog, this is how, whatever, it's there. Like, it's super easy to fix. And of course, it will enable us like reliable, repeatable, and any kind of benefits for integration tests without hitting and box or QA environments that might be flaky. Cool. So this whole third party now live in a container, but it's still but it's still doing the job. Let's see the code. This is actually the easiest part. The easiest part is the last one. Let's move on to the service virtualization branch. And then normally when we test those things, let me show the fraud system. I have this fraud check. It's super silly thing. Like we are checking if there's something that is no fraud detected or if it's a fraud detected. And I'm just saying here in the mocks, this is the normal way we do mocks, like more or less. Super silly again, but like I'm creating a builder for that, saying fraudulent, like it's fraud, no, false, and a message, transaction approved, and then I'm using the mock to say, hey, when you have any string and it's a get and you have any other parameter and the response should be fraud check response, then return HTTP 200, okay. And then I'm just doing an assertion that the response like is fraudulent is false and that message is transaction approved. Cool. I'm actually adding the behavior to the mock. It's a normal thing we do. And then for fraud detected, I'm literally doing the same, but I'm saying, hey, when those things happen, it's fraudulent. And then assert that it will be fraudulent. Okay. This will happen. This will actually works because it's mocked. So I can basically define any behavior. But what I mock here is not. I didn't have the mock here. Mock container. Anyway, run. What's happening? No qualifying bean again. Anyway, let me show I'm running the wrong one. Yes, I'm running this one. It should be this one. Of course, that will fail. See, everything is functioning because I'm running through mocks. But when I want to use sandbox environment, then it's a little bit harder. That was actually that test that run. So I have another test here where I'm saying, hey, I need to hit this sandbox QA vendor, whatever. And then I'm sending my super secret API key. And then I have the same test. But note that I'm not mocking anything. I'm just hitting that. And a normal thing, if I run sometimes, let's see, it failed because it's off. I could not actually connect there, right? And then it's a problem because I want to run the test. I want to make sure it's really working without mocks, but not working anymore. How I can fix that? Of course, with WireMock. So when we need to actually hit that endpoints, what we are doing here, I just have a service utilization folder just to show you a silly example where, if you guys are not familiar with WireMock, normally we do mappings, right? The request and response. So I have this fraud success, and this fraud success will show the following. When I have the request, which is a GET to API fraud check with any amount and any transaction ID, and with this secret fraud key as the header for X API key, then responds 200, which is okay, and actually respond this file, which is the JSON, which is response body. This file is in the files, it's success, which will show fraudulent false and message transaction approved. When I want the failure part, what I'm doing here to control, and of course we will control those things with data, I'm saying, hey, every time I have a request with GET for API fraud check, but now with the amount 4 times 9.2 times 9 for any transaction ID, for my secret fraud key for as a header, then respond in the response body as failure, which will be fraudulent true, transaction flagged as suspicious, due unusual access or whatever. Okay? And for WireMock specifically, what I'm doing, just creating a Docker Compose here. You can use through code. They have an alpha library nowadays you can actually do everything that I'm doing here through code. So it can be a little bit easier, but this is not the way we want to do through service utilization. And I'm going to do it through Docker Compose, creating a Docker image just to be able to share this with any other teams or deploy in an environment that I can control and everyone can hit. Basically, I'm using the latest WireMock. I'm naming this container as mock fraud. I'm doing the port bindings, and I'm saying, hey, in the files, that is this files that I have here, that's my folder, move it, copy that to the home WireMock files in my mappings, copy to the container mappings, and there's the default entry points for that. I will run this Docker, and you guys can see that the WireMock have started. So I can see WireMock here. Cool. What I will do now, it's running on 8080, right? Port 8080. Cool. So in that task that I have, search test again, fraud. What we can do, we can change now this to localhost and 8087, 8087, because 8080 is internal. Let's run it. Oops, did I miss the port already? Now 8080 What's happening? Jesus Christ. Spring again. Data source. What's happening in my talk? Wait a minute. What's happening? Let me do this through my main branch. I don't know what if I did a wrong update, but it seems that something is off. Let's stop this. Let me just remove the change. Let me go to the main branch because the next one will be from the main branch anyway. Let me just, to be sure, clean. Everything looks fine and looks fine. Let's do it again. Service utilization. Let's run the Docker Compose. It will run. My compose is saying that port binding is 8087. Cool, the external one. So fraud, no, not fraud, event, a fraud. Here, cool. Let's run again. If it's not running, you guys can believe me that it should run. Okay, cool. I have a different error, but you guys can see that it's run, right? Because I have the Docker. If I just stop Docker, let me just stop for a moment, and we see the same result, different result. Let me stop the Docker image and run. Then it's the same error. What's happening in the demos? Connection. API connection. Yeah, cool. And here it's connection as well. Yes, we are in the correct path. And then let me start that compose. And if it's not running, I just jump into the next one. I'm sorry. Docker running. And here, wire mock, running as well. And then, or test. Connection refused. No, now it's Jackson for some stuff. No, it should be connection refused, not Jackson. Anyway, I would normally do exactly like I would do in IntelliJ, just AI explain this to me, but I just go to the, type fraud check. I will, you're checking ID, no, whatever. You guys can believe me that you can, as soon as we run this, run the wire mock, we will have a variable, the localhost 887 API fraud, and then we can do all the requests and it will reply properly. I don't know why now it's not working. Okay. Let me jump into the next topic that I know that is working, that I just tested before I jump in here. And we'll see how to test the synchronous part. But before, let's get the takeaways for that. So when we run through service virtualization, we didn't work it here. So we can have like predictable, reliable, and isolated mocks for testing. Creating this Docker approach will allow us to reuse across teams without any manual setup, without anything like extra. And we can actually treat this as a software development as well. So the release process can move independently of any third part. So every time I have a difference in the third part, I just update everything that I have in this container, set a new semantic versioning, and continue with everything. If I need to mix it up, create more stuff, I can just treat this a normal development process and cycle. Cool. And the last one, which would be the easiest one, testing asynchronous events, because time is everything. So it won't be exactly like this that I will show in the example through the code. But imagine that, of course, we make a payment. A payment will send an event, and this event will be in an event listener, and then other microservices will try to consume this event. But actually, this when I have a service, of course, I can make a subscription to that event listener, and then I'm just pulling, right? But most of the time, this is not most of the time, all the time, it's not synchronous, it's asynchronous. Then it gets a little bit of time to get those messages. But I want to have a way to test that, because it's important to see if anything that I'm sending is exactly what should be consumed, or if all the metadata, the main data that should be there, it's there. Okay. If we try to run without synchronization, it will fail, but we need to have a way to add synchronization on that. Let me show the following. Remember that the service that we have here, it will actually send from a Kafka producer just some metadata. Timestamp, the payment type is updated, and all the payment information. As soon as I create as well, that will update. As soon as I create, will be the same stuff, the timestamp that was created, and the information about the payment. Okay, so I'm sending to a Kafka. And when I send this and I need to test, of course, Kafka has its own way to test that, but there's a even like easiest way to do. But the problem is, as soon as I try to test it, events. So I have one here, which will fail. It's a simple test that I have an event. I will send the event to a producer that I have, and I will try to assert if the event is the same, with the same metadata from this payment object that I created. If I run this, and by the way, I have configured here Kafka through a container, right? So Kafka container, using the latest from Confluent, having a dynamic port, which is the normal way we do. But you can see that failed. And it failed because it, could not get the metadata. Click here. Yeah, because it wasn't expected, it was empty. This is a real common problem. And then you can see that system based on events, queues, wherever that is asynchronous, have timing uncertainty. The integration test will fail, of course, because of this delay of consumption. And we are tempted to add some slips like thread.slip to that. But this is one of the worst ways possible. Because imagine like we want speed, like the Lightning McQueen. So if you add a thread slip of 5 seconds, try to imagine how many tests you can run in 5 seconds. Not regardless, but let's say integration test. You can run a lot of integration tests in 5 seconds. Or if you add 5 minutes or 10 minutes of waiting. How we can solve that? We need to synchronize those tests. And to synchronize those tests, one of the best Java libraries for this is called a utility. So a utility can wait for expected conditions dynamically. So we will avoid fixed timeouts and make the test more resilient. And it will be more realistic with integration tests if any any problem that we face with this asynchronous requests. So what we'll do now, we'll just use the library to say, hey, test that, see if it's there. If it's not there, just wait a minute, take a look again. If it's not there, wait a little bit more, take a look again, and do this all the time. So how is in the code? I have another test. This is the same as the previous one, but then what is the difference here? We have our utility. Basically, hey, our utility await at most 5 seconds. It's a lot, I know, but I just add 5 seconds just to show you that it can wait until we can have a lot of different things to play with, and we can even create different conditions and custom conditions, but that is until asserted, and I'm trying to assert information. So what our utility will do here, we try to assert this information, it will throw an exception, but our utility says, okay, I still need to wait for 5 seconds, so I will ignore the exception, and I will pull it again. And the pulling part is half of second, so it's every half of second, it's trying to pull in and see. If it's 5 seconds, it's throwing the exceptions, the assertion error, then it will fail. Of course, it will try until it reaches the 5 seconds. So it's really nice because it's I tried pulling to see the information is there. And if I run this one, you guys can see that the test will be running a little bit for 1 or 2 seconds. Wait for that. I assume it's a variable now. Yeah, 1, 2, boom, pass. Because it was waiting for the data to be a variable, whatever the topic to be consumed. If I run it again, it will be the same thing. It's running there. Then we'll show the test. More or less 2 seconds, 1, 2 seconds, pass. Then we have, in a super easy way, the solving the problem of asynchronous stuff. With like few lines of code, you can actually nail it and be super confident that anything that you run in anything in asynchronous systems will work as a sharp. Cool. Takeaways for this part. So async flows require resilient test assertions, and our utility will help you to wait just enough, not too long, of course. And this will maintain a realistic test while ensuring everything is correct when you're playing with events or anything that is asynchronous. Cool. So we learned 3 different things in a super easy way. How to support multiple databases, and we saw how to do this running parallel. How to support mock dependencies through a service virtualization, and how to test asynchronous requests using a super easy library with few lines of code with our utility. And then we have 3 actually real problems when we are trying to test any kind of distributed system in some different architectures. But you can see that it's super easy to fix those. And it's basically the basics, as I was telling you before. So with basic stuff, basic test approach, you can actually solve any kind of a problem in any kind of complex distributed system, or not complex, but even easy, you can solve them all. Cool. Thank you so much, guys, for joining this talk. This talk is available. The slides, the project is all available. I will take a look and fix this as well. Just make sure you guys can run in your machine, okay? Thank you so much.
Okay, we have time for a few comments and questions. Seems a lot of people have problems with H2 and Postgres, or moving from one to the other. So I guess that's one of those issues you want to solve with your approach?
Yeah, I think that his problem was he was using H2 and then was trying to just go to Postgres, and then he needs to do something extra to make it work on Postgres. But at some point, H2 is faster. You need to go back to the H2 just to do few stuff, and then you have a problem because you did change the pro stickers. I think it's more or less like this. And even
Yeah.
in terms of features, then some things that is supported on one is not supported in another. So it's common. And then that's why normally we try to avoid as much as possible, like in-memory database. Choose the one that you think that's more performatic one, MySQL, Postgres, whatever. Make it default for everything. If you need to support more, do that approach with like multiple databases doing in your CI/CD process.
Yeah, good remark. Yeah, Johan Hutting says a bit the same. He also stopped doing H2, I think, for that same reason. If you go from one to the other, and what you're saying is yes. So the fix is using test containers to run RealDB is
Perfect.
test whatever you're using in production. That's a bit the message, I think. Also, Johan says sample and fast tests are a way to go. Couldn't agree more.
Yeah.
And then, yeah, some people are fans of the tools that
Yeah.
you're using, WireMock, awaitability. Even while the demo of WireMock didn't succeed, you totally
Yeah.
convinced me with what you were showing. And one question, couldn't we just use Spring Cloud WireMock and auto-configuration?
Oh, of course. Yes. Yes. You could. That is what is my take. Of course, you can use Spring Cloud WireMock. At some point, you need to distribute that. It just needs to define the approach for it through containers, to Spring Cloud WireMock, to the WireMock service they have. So it's basically the way you want to go.
Yeah. Okay. And one last tip from François Martin: don't use native queries in Spring Boot, or you will have a bad time switching between databases.
This.
Yeah,
sure.
if you have different database
Yeah,
applications
or
behind it, yeah.
you can use Liquibase or other tools to try to help you with that.
Okay, good. Those were all the comments I marked to show you.
Nice.
Thank you for the presentation. Thank you to make testing a bit more fun again with all those additional tools. And thank you for your time, and also everyone thank you for joining this session and or watching the recording afterwards. Have a nice evening.
Thank you, everyone.